Mazawakma, roll number 21 T76, and I am going to perform lab number 10 of DSP, in which we have to design frequency sampling method. So its objectives are to implement FIR filter using frequency sampling method. So we approach towards this task in which we have to perform the task that are given in our book. So let's move towards our first task. In this task, we have to design a linear path low pass FIR filter with 25 coefficients using frequency sampling method. Let the cutoff frequency be 2000 Hz and assume a sampling frequency of 8000 Hz. Now we will plot its magnitude and phase response. So we will move towards the task in which we have first use CLC command that clear the window, and then we use the code that is given in our book in which we have given the sampling frequency H1, the magnitude specification V1, the design filter. For filter application apply, we use FIRL function. So H1 and V1 we use calculate magnitude frequency response. Then we keep H2 and apply filter on it, and then for that we use calculate frequency magnitude frequency response. Like that we will calculate the phase and plot them. So when we run them, see that we are getting a graph in which from 0 it is getting opened, and at 20 and at 24,000 hertz, 24 and other it got triple. Like similarly in the phase at 2400 hertz it got triple. So it is our task number 1. Now we will move towards our task number 2, in which we have to again upload plot the FIR filter in which we have sampling frequency, oh sorry, in which we have sampling frequency H1, B1, H1 like in the previous one we are given. So similarly we have to plot magnitude frequency response, and then we will plot the phase frequency response. And when we run this program, as you can see that at 1000 hertz almost we got the ripples, and at this is task number 2. And now we will move towards our task number 3, in which we give the sampling frequency, carrier frequency, cutoff frequency, and number of taps, filter order. So for we have given here the 3 tap filter and H desired magnitude specification for low pass filter, and like that we apply the row for 3 tap. So when I run this program, as you can see that the filter is of 3 taps. So here we get the graph of 3 tap filter. Now we will move to the graph number 4, in which have same function in which we have sampling frequency, frequency, and number of taps, like the frequency from 0 to make stick. And here we have to plot the like in the previous one we plot the low pass filter, but in this one we will plot the high pass filter by using the earlier conditions. So when we run this program, we will get this graph. This is of 3 tap filter. Now we will move towards the task number 5, in which we have to use CLC command. And now we have to plot the previous function, like in the previous one we plotted the high pass filter. Here we also plot the high pass filter, and then we use a but with the 5 tap filter, not with the 3 one, with the 5 tap filter in this program. Here you can see that we got the graph of 5 tap filters. Like now we will move towards the task number 6, in which we have to use the 5 pass filter, but we have to plot the low pass filter with by using inverse discrete Fourier transform. So when we run this program, here you can see that we got the graph of By using the inverse for discrete Fourier transform, we get graph. Now the task number, this is the last task number 7, in which we have to lower cut by using lower cutoff and high cutoff. Per cutoff, we will plot the filter frequency by using frequency band, desired magnitude response, and a filter FIR2 command using and plotting command as label by label title grid on, and by using this we will plot them, and here we got the graph frequency in the phase and in the magnitude response. This is all for lab number 10. Thank you.